Everyone, today we are going to discuss types of waves. Basically, we know that waves is a form of energy. These are a form of energy. So waves are being divided on two bases. Okay, they are being divided. Division of waves is on two bases. Okay, so one is on the base of medium or media, and another one is on the base of direction of movement. Okay, how the wave moves. On these two bases, waves are being divided. According to medium, on the base of medium, waves are of two types. One is mechanical waves, and another one is traveling waves, progressive waves. Progressive waves are simply called traveling, or sometimes it's also called harmonic waves. Sometimes more specifically it is also called electromagnetic waves. Electromagnetic waves. Electromagnetic. So mechanical waves, these they require a medium. Okay, they need a medium. Okay, medium of air, liquid, or solid. Okay. On the other hand, the second point is that mechanical waves do not need they also need a source of production. They require a source of production. They do require a source of production. They cannot be produced by their own. They need somehow another force or another agency or another energy for their production. Is that clear? So these waves, they are being produced by some other source. Okay, like for example sound waves. Okay, sound waves, it requires a medium and this source of production. It have a source of production, like sound is not produced by its own. Is that clear? On the other hand, the progressive waves, it's totally opposite of that of mechanical waves. They do not need a medium. Okay, no medium, and hence no source of production. Okay, they are produced by their own. They do not need any other source of production. And for example, light. Okay, light waves, sunlight waves, and we cannot produce it. It's produced by their own, and light waves also do not require a medium. That's why we can see the sunlight, but we cannot hear the sound of sun. So these are basically two types of waves. One is mechanical waves, another one is progressive waves. The other point is that direction of waves. On the basis of direction, waves again are of two types. Number one is transverse waves. And another one is longitudinal waves. Okay, transverse waves, as the name indicates, transverse. It's like ups and move it, the waves moves ups and downs to on the direction of wave. If this is the wave, transverse wave, they will move perpendicular up and down. The word perpendicular is also being used in your book. That means that the wave, they are making somehow 90 degree transverse, 90 degree right angle triangle. Okay, the wave, they are moving at right angle, okay, towards the direction of the wave. You can see over here. So these waves, they move in this way, okay, ups and downs, perpendicular towards the direction of the wave. Longitudinal waves, on the other hand, these do not have moving ups and downs. They move parallel. Okay, basically they move parallel. How parallel? Like they move in this way. They move in this manner, okay, parallel. Okay, the waves, they move parallel. They are not crisscrossing each other. They are not making any angle like ups and downs. Okay, is that clear? So these waves, longitudinal waves, let me draw this for you. Okay, so those part of the longitudinal waves where the wavelengths, okay, where the vibrations, they are far apart, they are not too much close with each other, these are called the rarefactions. And that portion of the longitudinal wave where the vibrations, you can see the vibrations, where the vibrations, they are too much close with each other, this is called compressions. Okay, so the waves, they are making rarefactions and compressions, and this way they move. Okay, on the other hand, if you see this transverse wave, they are moving ups and downs, making the crust. Upper portion of the wave is called crust and the lower portion of the wave is called trough. Okay, so this is how the wave move. Another important point related to waves is that I told you earlier that waves are being divided on the basis of medium and direction. Okay, so sometimes there are some waves that can be transverse and that can be mechanical waves as well. So this mechanical and this progressive waves, and here transverse and longitudinal. Okay, an example of mechanical waves, as I told you, is sound. Okay, seismic waves. Seismic waves is also, and we call this earthquake. Okay, earthquake waves are called seismic waves. Water waves, all they need a medium. Okay, progressive or electromagnetic waves, like for example light, X-rays, okay, and all such things, gamma rays. Transverse waves, example of transverse waves is light, X-rays, and example of longitudinal waves is sound and seismic or water waves. Now keep in mind that the mechanical waves itself, the mechanical waves can be transverse waves sometimes, and sometimes the mechanical waves, some of the mechanical waves, they move in the they move like longitudinal, and there are some mechanical waves that move in both transverse waves and longitudinal direction, like earthquake, like seismic waves. They have both direction. When the earthquake happens, the earth it shows the direction like both transverse and longitudinal, both parallel and perpendicular. So, and progressive waves, on the other hand, the waves can also be, again I will repeat that the waves can also be have a direction of a transverse type direction, and the waves can also have direction of longitudinal and both type of direction. Okay, but most of the time the progressive waves, they show the direction of, they show the direction of transfer. They move perpendicular most of the time. The X-rays and gamma rays, most of the time they move in a perpendicular manner. But mechanical waves, they have the direction of both transverse, longitudinal, earth, and both. Okay. So again I will repeat that on the basis of media, mechanical waves and progressive waves. On the basis of direction, waves are of two types, transverse and longitudinal. So the mechanical waves can be transverse and longitudinal and both, and the progressive waves can be transverse and longitudinal as well. Okay, but most of the time the progressive waves or the electromagnetic waves, they have a transverse type of direction. Is that clear?